Hello and welcome to this quick video about weight, and this is for a unit of forces for P2 for GCSE Science. Now, when we're talking about weight, weight is actually a force and it's measured in newtons, and weight always acts downwards, and by downwards we mean towards the center of the earth. So if I was to show you a diagram of the earth with somebody standing on it, the weight of that person will always be towards the center of the earth. So if they're standing on the top, it goes that way. If they're standing on the side there and at the bottom of this diagram, the weight would always act towards the center of the earth. Now, your weight depends on, or the weight of any object depends on two things. It depends on the mass of the object or the person, and it depends on the amount of force that it's being pulled towards the center of the earth with. Now, it's very important to remember that mass and weight are not the same thing. Mass is measured in kilograms, weight is measured in newtons. In everyday English we do say something weighs 10 kilograms, 20 kilograms, and it's okay to do that, but technically in physics mass and weight are two different things. To work out weight we need to know the mass of an object and multiply it by the amount of force that's being exerted on pulling that object towards the center of the earth. And this force here has a special name. It's given the letter G, and it actually stands for gravitational field strength. And for planet Earth, this gravitational field strength is always the same. It's 10 newtons per kilogram. So every kilogram of mass, you're going to have a weight of 10 newtons pulling it towards the center of the earth. It's different for different planets and different parts of space because it depends very much on this force of gravity. Now, the formula that you need to know, then you might have guessed this already, is that weight is mass times G. And in terms of the exam, they'll tell you what to use for G. Most of the time, I've only ever really seen them use 10 newtons per kilogram, but if they want to use something different, they'll tell you so that you don't get confused with that. The meaning of these letters is W is for weight, mass is obviously M, and G is gravitational field strength. And as I say, they'll give the value of that to you to use. This is actually given on the formula sheet in the exam. So this formula here and the meaning of each different word or each different letter is given. What they don't give you is the units. So remember, for weight it's newtons, mass it's kilograms, and gravitational field strength is newtons per kilogram. Okay, so this is the formula, and we can actually use it to determine the weight of this boy here. So let's just say, for argument's sake, he has a mass of 50 kg. We know the gravitational field strength on planet Earth is 10 newtons per kilogram, so we simply put it into the formula. Mass is 50, G is 10, so this boy has a weight of 500 newtons. Okay, so if we know that the weight depends on these two things, we know that a bigger object that has a bigger mass is going to have a bigger weight, and that actually just seems to make common sense, really. So this will have thousands of kilograms of mass, and each one of those kilograms of mass will be pulled towards the earth with 10 newtons of force. So let's have a look at how that works in different scenarios. So we've got our truck here, and imagine it's there on planet Earth, and let's give it a mass of 1,000 to keep it nice and simple. And we know that gravitational field strength on planet Earth is 10 newtons per kilogram. So to work out the weight, simply a case of 1,000, if we use our formula from the previous slide, 1,000 times 10, and that will give you a weight of 10,000 newtons. Now let's take that same truck and transport it to the moon. Very easily done on my slide here. And let's see what its weight is here. Well, we know the mass is exactly the same. The mass doesn't change, whether it's on the moon, whether it's in space, or whether it's on planet Earth. The mass stays the same. So we've got a mass of 1,000, but the gravitational field strength on the moon is different. It's about 1.6 newtons per kilogram. And again, in the exam, if they're going to ask you to do this calculation, they will give you the value to use, so you don't need to memorize that. But in this case, it's 1,000 times 1.6, and that will give you 1,600 newtons of weight. So you can see that an object, whether it has a different weight depending on whether it's on Earth or whether it's on the Moon, and that's why we say things are always lighter when they're on the Moon, because it has a lower gravitational field strength, and therefore things have a lower weight. What would happen if you put this truck into deep space, very, very deep space, where there was no gravity, therefore no gravitational field strength? Well, we still have the mass of 1000 kg, but if we had zero gravitational field strength, its weight would actually be zero. And that's why we say that in space objects are weightless.